Ladies and gentlemen, welcome back to Mr. Lee's physics class. Today, we are going to learn the new chapter, Chapter 2, Capacitors. The subtopics for today is Capacitor and Capacitance. The aim of study today, of the lesson today, is to understand the capacitance, capacitor in series and parallel, and also the energy stored in a charged capacitor. Objectives. In this lesson, students define capacitance and use the formula C equal to Q over V. And objective number 2, derive the use of the formula C equal to epsilon A over D for parallel plate capacitor. Objective 3, describe qualitatively the action of the dielectric in a parallel plate capacitor. Objective number 4, derive the use of the formula for effective capacitance of capacitors in series and in parallel arrangement. And last objective is use the formula of U equal to 1 over 2 QV or U equal to 1 over 2 Q the power 2 Q squared or Q squared per C. And last, U equal to 1 over 2 CV squared. Assume period knowledge. Students should be familiar with, first, electric field. Second, the uniform electric field between the parallel plate of a capacitor. 3, charge, potential difference, and also the energy. Ladies and gentlemen, let's go to the introduction of the lesson. In the slide, we can notice that there are various types of capacitor. So this device is used to store charge. And today, we will learn more about this device, that is capacitor. Ladies and gentlemen, let's look at the second slide. Introduction. In this lesson, you will learn to define the capacitance and use the formula of C equal to Q over V. Okay. Next, derive the formula for the parallel plate capacitor and describe quantitatively the action of dielectric in the parallel plate capacitor. And next, derive and use the formula for the effective capacitance of capacitor in series and parallel arrangement. So use the formula of U equal to 1 over 2 QV or U equal to 1 over 2 Q squared over C or U equal to 1 over 2 CV squared. Let's look at the circuit. Let's say we use a direct current. We use a cell or battery. We connect directly to a capacitor. Inside the capacitor, the concept of a capacitor means that there are two plates which separate with a distance. So this is the concept of the capacitor. And then how the capacitor function? Once the circuit is off or the circuit is on or the circuit is connected, we notice that the current flow and cause the charge collect at both plates, which are opposite charge to each other. The red color is electron, which with the with negative charge, and positive is the positive charge. So when zoom in, we notice that the two plate separate with a distance, which the distance is either, okay, now we can notice that the distance, the medium between the two plates are A. So what will happen when the switch is on? Current flow and cause the charge collect at the plate. One of the plate will be charged negative, and the other side will be charged with positive charge. Now, definition of the capacitance. Once the switch is off, the switch is connected, we notice that the current flow and cause the, what is that? Cause the both plate charged with positive and negative. Meanwhile, actually, we pump the concept similar, we pump the all of the water to the other side. We notice that when the current flow through the circuit, the charge are collected at both plates. So this means that the capacitance, what is meant by capacitance? Capacitance, for example, the device, electronic device we learned before, for example, resistor. Resistor, what is the unit used for the quantity of resistor? It is resistance. Resistance, what is the meaning of resistance? Resistance, first, the function of the resistor is used to limit the charge, limit the current. So resistance is the ability of the resistor to limit the current flow in the circuit. Now, what we learn today is the capacitor. The quantity used to measure in the capacitor is the capacitance. First, what is the function of a capacitor? Capacitor is a device used to store charge, to keep the charge. A neutral capacitor means that none of the charge inside. But once the charge is stored, this means that the capacitor similarly, okay, the negative charge will store in one side of the plate, and positive, all of the positive charge will store at the other side of the plate, which the medium between the two plate, either vacuum or air. From here, capacitance is the quantity used to measure used in the capacitor. Capacitance means that the ability of a capacitor to store charge. The higher the capacitance, the more the charge can be stored. A capacitor is like that. Once we connect to positive, if we connect to positive, this side will charge, the right side will charge with positive because it's connected to positive terminal of the battery. Which plate? The plate which we connected to the negative terminal will charge negatively. The Formula for the capacitance, the general formula for the capacitance, C equal to Q over V. Q is the amount of charge and V will be the potential difference, or we call that is voltage. How many volt? Let's say, okay. Let's look at the next slide. The C equal to QV, and we arrange Q equal to CV. The charge stored in the capacitor depends on the ability, the capacitance times with the V. Now, the potential difference, both of them are 5 watt. V is 5 watt. Now, the difference is C, capacitance. The capacitance, 10 microfarad. The unit for the capacitor is farad. So the first one, the capacitor of 10 microfarad times 10 upon -6, yeah? And another one with 100 microfarad. We look at the two capacitor, two different capacitor. Now we see what are the difference. First, Q equal to CV. The C is 10 to the power -6 microfarad. 10 to the power -6 farad times with the 5 voltage. Voltage, potential difference, voltage 5. We get at 50 microcoulomb. That is the charge number of charge stored. And next, it will be 500 according to the formula Q equal to CV. So the higher the capacitance of a capacitor, the more the charge can be stored. This one just 50 microcoulomb, but the second one with 100 microfarad, the amount of charge stored is 500 microcoulomb. As a conclusion, we can say that the capacitance is equal to charge on any one plate divided by the potential difference across the plate. That means C equal to Q over V. Ladies and gentlemen, let's look at the derivation of formula for the capacitance of a parallel plate capacitor. That means that both plates are put side by side. So we said that this plate with the parallel plate capacitor. If I increase the area, so you notice that once the area increase, that means that the greater the area, the greater the capacitance. So means that the capacitance is directly proportional to the cross-sectional area of the plate. Again, the capacitance is directly proportional to the cross-sectional area of the plate. Meanwhile, the greater the A, the greater the C. As a conclusion, once the C increase, the charge can be stored on the plate also increase. Number of charge which can store or stay at on the plate also increase. Now, what will happen to the distance of the separation between the two plates? Once the distance of the plate increase, we notice that the capacitance also increase. Okay, sorry, 1 over D also increase. Means, well, this will be like that. Once the plate increase, the distance of separation increase, the capacitance will decrease. So once the area, cross-sectional area, just now is the distance. Okay, sorry, this one. Once the separation plate reduce, the distance of separation reduce, as what we can notice that 1/d also smaller. That means that the capacitance will be higher. As a conclusion, C, capacitance is inversely proportional to the separation between the two plates. Now, if the two plates with the separation in the medium of vacuum, that means none of any A molecule or any material in between the two plates, just vacuum. Another one is the with dielectric. First, the definition. Dielectric constant epsilon R of the material is defined as ER equal to C over C naught. That means that will be a constant. Dielectric for A is 1 point. If there is A, if vacuum, if A, 1.0005. For paper is 3.7. Glass is at, ceramic at T to 1,200. That means it depends on the density. Okay, different material with different dielectric constant ER. Okay, ER is come from C over C naught. Now we look at here. The derivation of formula for capacitance of a parallel plate capacitor. Both plates are arranged in parallel with a distance, where one side will charge with positive, another side charged with negative. Positive and negative. Meanwhile, what happened? We look at the two plates. That means that we notice that when starting, initially, both of the plates are neutral. Once we connected to the current, the positive terminal and negative terminal, the current is flow during charging. Once the plate, both of the plates fully charged, observe the current, the arrow, the current will stop flowing. At this time, what happened? Actually, the capacitor charged with positive and negative charge. Because there is a medium in between the two plates, cause that there will be a potential difference. Easiest, we said that if I use a 5-volt battery to charge a neutral capacitor. Once the capacitor are fully charged, this capacitor also charged with maximum 5 volt. If I use 5 volt of battery, charge a neutral capacitor, when the situation of the capacitor are fully charged, that means that now the capacitor itself become a source. In the other way, said that it become a temporary battery of 5 volt. This is 5 volt, right? Once it's fully charged, it also become, when fully charged, the capacitor become a battery of 5 volt, but temporary only. Not as strong as the battery. Now we go back to the slide. What is the derivation? According to the formula, C equal to Q over V, and E is equal to Q over epsilon A, because they are one flat charge with positive and one flat charge with negative. So the electric field strength, because charge opposite charge with a distance, with a potential, with a distance separation, it produces a potential difference. At the end, E equal to V over D. Next, by using the formula, C equal to Q over V, which equal to epsilon A over the D is the separation of the plate. As a conclusion, we get that C naught equal to epsilon A over D, a constant. Okay, the capacitance, C naught is the capacitance of this plate. Just now, as we know that C is equal to Q over V, right? C equal to Q over V, that means that the separation in between either is vacuum or A. The separation, the medium in between the two plates is A. C equal to Q over V. If we add a medium in between the plate, positive plate and the negative plate, that means that the new capacitance is equal to epsilon A over D. Okay. What is the function of the object in between the two plates, which we call that is the dielectric? This dielectric function as an insulator. It prevents the charge jump over each other. It prevents the electron, the negative charge, jump from one plate, from the negative plate to the positive plate, the electron. Meanwhile, if we using A in all the vacuum between the medium, between the two plates, this means that electron possible move in vacuum. Electron possible jump. To increase the resistance between the two plates, to increase the resistance between the two plates, to avoid the charge on both plates jump each other, jump to the other side. This means that to avoid the charge from the negative, avoid the negative charge, jump from negative plate to positive plate. So we add a medium in between the two plates. Dielectric means that the material we add into the medium must be insulator of electric. The greater, why we add the insulator in between the two plates? The purpose we add is used to increase the resistance between the two plates to avoid the electron move over. If the electron cannot move through the dielectric medium, that means that it's become a perfectly charged capacitor. Meanwhile, it can store more charge. We can charge it with higher potential difference, because the electron will not, electron or the charge, positive charge and negative charge cannot jump over the medium. Okay, so as a conclusion, we said that dielectric is used to increase the capacitance of a capacitor. Dielectric is used to increase the amount of charge stored in a capacitor. Let's go to the next slide. Let's say application for the formula. If the area is 1 cm times 10 cm, this means that it will be the cross-sectional area is 10 cm square. Convert to meter square is 10 to the power negative 1 times 10 to the power negative 3 meter square. Permittivity is 3.4 times 8.85 times 10 to the power negative 12. For example, if the plate separation is 0.05, by using the formula C equal to epsilon A over D, we substitute all the value. So we get that the capacitance of the capacitor now is 601.8 picofarad. Okay, so farad, okay, picofarad. So next, consider there are two plates charged with positive and negative each other. Once the two plates are near to each other in the medium of A or vacuum, this means that it will create a region where we call that is the electric field. What happens when the charge, when the neutral charge in between, we put the, let's say, any molecule with neutral charge, negative, positive together. One charge with positive, negative, that means neutral. Once we put in, there will be well arranged. Positive with the negative. The positive will go to the other side and attract the negative against. So we notice again, without well arrangement, at the end, all of the molecule are arranged in order. That means that what we add in actually, once we what we add in between the two plates, they are the material, the dielectric material. When dielectric material add into the electric field, the neutral charge in the dielectric, all of them are well arranged. So it's still the number of negative and number of positive are neutral, okay, are equal. So this dielectric consider is neutral. Next, we look at here. The action of dielectric in the parallel plate capacitor. So we notice that the electric, now all of them are arranged where positive will attract negative and repel the positive. The positive attract negative. So positive and negative always side by side to each other. So from here, we can conclude that the capacitance is directly proportional to the area of the cross-sectional area of the plate. Don't just write area only, because it depends on the cross-sectional area of the plate. So C, capacitance is directly proportional to the cross-sectional area of plate. The capacitance is inversely proportional to the plate separation, to the distance separation. The dielectric increase the capacitance of a capacitor, where dielectric actually is an insulator. And the capacitance C of a parallel plate capacitor is given by C equal epsilon A over B. And last, dielectric plates in a parallel plate capacitor can increase the capacitance of a capacitor. Now, we look at the capacitor which arranged in series. Capacitors are arranged in series arrangement. That means that once we arrange in series, that means that this will be the positive and negative, right? So this is positive plate. Why I cannot? Okay, positive plate, positive terminal and negative terminal. The positive will cause the other side charged with positive. That means that this will be dielectric insulator medium and cause the other side negative. Negative will attract with the other, cause the other side to charge with positive, negative. And this side is negative through the negative terminal. Now, let's say V. We notice that this is a V. This will be the V1. V1 is the voltage, because if this charge is positive, this charge is negative, consider it become a battery, a source of charge. So let's say a battery, another battery. So when the two battery arranged in parallel, in series, this means that V1 plus V2 equal to V. Okay. The potential difference across the capacitor. V1 equal to Q over C1, V2 equal to Q over C2. Depends. The charge still depends on the voltage and also the capacitance. So supply of V, that means V total of the V will be equal to V1 plus V2. Why? Because V equal to V1 plus V2, because in series, the total of the voltage are shared together with the capacitor 1 and capacitor 2. If both of them with the same capacitance, that means that V1 will be equal to V2. So the V is inversely proportional to C. The greater the C, the smaller the V. The greater the C, the smaller the V. Okay. Oh, sorry. Sorry, I switched off accidentally just now. So from here, substitution, the V1 equal to Q over C1. At the end, we get that the total charge, total C, C1, C2. As a result, we can set that because the total charge are equal. So 1 over C equal to 1 over C1 plus 1 over C2. What is the meaning? That means that initially C1 and C2, once we combine, we arrange in series arrangement. Similar, we combine the two capacitor, become a single capacitor. Again, we look at here. The two capacitor C1 and C2, which arrange in series, means while C1 and C2 combine, it becomes a C. We can set that it combined become a single C, where the C is referred to the C total. That means 1 over C equal to 1 over C1 plus 1 over C2. Now, we look at here. What happens if we arrange the capacitor in parallel? If parallel, that means that voltage across are equal, right? The concept. So what we can notice that if this is positive, both sides charged with positive. This side negative terminal cause the other side, the older right side of the capacitor charged with negative charge. Now we look at the capacitor in parallel. Q1 is equal to C1 V1. Q2 equal to C2 V2. Total charge in the circuit. That means Q equal to Q1 plus Q2. Okay. Q1 plus Q2, that means that the charge Q1 plus Q2, total charge. That means that if we arrange in parallel, that means that the charge produced will be higher. And substitution, CV, Q equal to CV, right? C total, V total equal to C1 V1 plus C2 V2. Because these two capacitors are arranged in parallel, the V total will be equal, the total voltage of the battery will be equal to the voltage of the first capacitor and the second capacitor. No matter how big is the capacitance, both of them will have the same voltage. Reason? Because they are arranged in parallel to each other. They are arranged not only parallel, the two capacitors not only arranged parallel to each other, but also parallel with the source of the electric. Now, sorry. So total capacitance will be equal to C1 plus C2 if arranged in parallel. As the conclusion, that means that the V still equal. So the C total is C1 plus C2. If we replace it, we call that is the effective resistance. So effective capacitance. So total capacitance. Next. Now we look at here the how to solve. If we have parallel, we have the resistance capacitor which arranged in series. First, calculate the capacitance of the two parallel. Solve the two parallel. If parallel, capacitance is C total equal to C1 plus C2, right? So that means 7 plus 3, it will be 10 microfarad. When series, it will become. That means that once we solve it, after we solve, it become 5. And the parallel we solve, it become can be represented by a capacitor of 10 microfarad. And this side with the 5 microfarad. So how to solve it? 1 over 5 plus 1 over C. Okay, 1 over C total equal to 1 over C1 plus C2, 1 over C2 plus 1 over C3. At the end, we solve it. The effective resistance is equal to 1 over 2. So that means that the effective capacitance will be equal to 2 microfarad. farad. Ladies and gentlemen, as a conclusion, we can say that the two capacitor connected in series, what happened? Okay, two capacitor connect in series, the charge on each capacitor is the same and equal to Q. The Q will be equal. The total charge stored by both capacitors together is Q. That means the both charge in series will have the same Q. And the potential difference V is shared between the two capacitors. V equal to V1 plus V2. If in the series, the effective capacitance is equal to 1 over C1 plus 1 over C2. This is in series. And next, if the two capacitors connected in parallel, the potential across each capacitor is the same. V is equal. In series, Q is equal. In parallel, V is equal. But the Q will be equal to Q1, Q total equal to Q1 plus Q2. And finally, the effective capacitance will be equal to C1 plus C2. Now, how about the energy stored in the capacitor? The positive charge and negative charge stored. We notice that when the switch is connected, current flow. Okay, so again, so we notice that this one, if the capacitor is fully charged, that means that, for example, we go to this one. Let's say, once we charge the capacitor fully charged, the current will go off. After the capacitor, the two plate charge. Means while the capacitor is fully charged. Okay, no current flow in the circuit. Stop charging. Now, once just now battery charge the capacitor, right? I replace the battery with a bulb. As I told you just now, the capacitor charged, it become a source of battery, a new battery, temporary battery. Once I switch on, so it's release charge until the bulb light off. Why the bulb light off? Because no more charge flow through the bulb and none of the electric energy convert to light energy. So the bulb light off, the light gone. Next, the energy, how we calculate the energy stored in capacitor. How much of the energy we can use these three formula? U equal to 1 over 2 QV, where U equal to 1 over 2, the V equal to Q over C, right? So Q times Q over C, that means that it becomes Q2 over C. If Q equal to, as we know that Q equal to CV, so U equal to 1 over 2 CV squared as well. As a conclusion, the energy is stored in the electric field of a charged capacitor. The equation we can use are these three equations. U is the energy stored in the capacitor. Ladies and gentlemen, That's are the concept of the capacitance in the capacitor we learned today. After this, I will send you one set of the question which regarding to today's lesson. I want you all solve it. I want you all try to solve the question. And please check your Telegram. After you do the question, after you finish the exercise, so I will send you the answer, the suggested answer. So please refer and check it. The question which I will post later, I will send to you. So we have 2 pages, which are question 1, question 2, question 3, question 4. Next page, question 5, question 6, and also question 7. 7 questions of the exercise. So ladies and gentlemen, please solve it now, and we will end today's lesson, and we continue again on next lesson. Thank you very much, and see you again on the next lesson. Bye bye.